So we've already looked at x, y intercepts. Now we're going to be solving linear equations by graphing and estimating solutions to a linear equation by graphing. So like finding the intercepts are also known as zeros and solving equations for x. Okay. Okay. Linear equation f of x equals x. That is the parent function. The parent function is when x is just by itself, there's nothing else happening to x. So we know our x-intercept here is 0, and it just goes straight through. That's our parent function. Okay? We're going to be seeing different manipulations with this to make our lines look steeper, go the opposite way, bunch of different types of lines. Okay? Some are going to be straight up and down, some are going to be straight across, just depending on what's happening to our parent function. Okay, but linear equations always start with this parent function. That's where they come from. Okay. The domain we will talk about later, but the domain is all real numbers and the range is all real numbers. Because lines, what is special about lines that we talked about last week? What's on the end?
Arrows.
Arrows. And what do those arrows indicate? That it's forever in all directions, right? Good. So here we are going to be solving algebraically. So we've done this before. We're just solving for x. Okay, they put a 0 in for technical error y, because remember that form I talked about? I talked about ax plus by equals c, that standard form. What was the other form I talked about, the other equation? Y equals slope-intercept form. M x plus b. Okay, we've talked about both of those. So this equation right here is very similar to this. They just plugged a 0 in for y. Why did they plug a 0 in for y?
So you can find the y-intercept.
Other one.
X-intercept.
So you can find the x and that x-intercept where it intersects on the x-axis. Okay, to help us graph. Okay. So here, this is what I was talking about with the xy table. So on your homework, I have, instead of written as f of x, I have y. Y and f of x mean the same thing. Okay? So whenever you see f of x, think of it as y equals whatever that is. Everyone write that for me. So whenever you see f of x means y. They mean the same exact thing. Okay? So, last week, how did we find our x-intercept from this? If we were given this equation, what did we do? Substitute what? 0 for y. Yep. All they did was plug in a 0 for y. Okay? And that would give us their x-intercept. How did they find the y-intercept then? Substitute a 0 in for the x to find your y. Okay, we did a lot of practice with that last week. So, we want to solve this algebraically. What does it mean by solve algebraically? What's our goal?
Find x.
Find x. Let's get x by itself. What do we do when we see a fraction? We don't like fractions. What do we do with it?
Make it a decimal.
Not make it a decimal. That might make it a little harder. Multiply by the denominator to what? To everything, right? Times 3, times 3. What we do to one thing, we want to do to all things. Why do we want to do it to everything, though? Why do we multiply every single term by that denominator? Why don't we just multiply it by the denominator? So it stays, I like what you're saying. I'm going to rephrase a little bit, though. So it stays equal. So we're not changing the value of anything. If we change the value of one thing, we need to change the value of all things so that it stays the same equation. Does that make sense? Okay, so here, what's left on the left side? Negative 2 times 3.
Negative 6.
Negative 6 equals 2x plus 12. Awesome. What's our next step to get x by itself? Subtract 12 on both sides. What's negative 6 minus 12? Negative 18 equals 2x. What's my last step? Divide by 2. X equals negative 9. Good. So you've done this before. Now that we're working with graphing, what does this give us? The x-intercept, right? It says x equals, so on that graph, if I drew a little graph, negative 9 would be over here. That's what it gives us. Okay? Same thing, but now we're putting it together with a graph. Okay? How do we solve here? We want to solve. What's my first step?
Multiply by 4.
Multiply by 4. What's 6 times 4? 24 equals negative 3x plus 36, yeah? What's my next step? Subtract 36. 24 minus 36. Negative 12. Yep, divide by negative 3. X equals positive 4. Okay? Again, what does this give us? The x-intercept. Well, the only one that we match is A. Did they graph it correctly? The x-intercept wise? How do we know if our line is supposed to go in that direction? How can we find out? So we have our x-intercept here. What did you say? We could find our y-intercept. How do we find our y-intercept? Can we really from this? No. So what would we have to do? Trick question. Can we find another point? No. Think way, 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 way back to 8th grade. What do you know about slope? What's our slope in this equation right now? That number right there. It's negative, so that means our slope is negative and our line is negative. Okay? That's way, way back. We'll do a review of that also. Okay? Here, what happens if we get to this point? Right, we normally would say no solution, right? Where would this one be?
2.
If I had a graph here, x or y?
X.
Yep, it would be right here. Yeah?
Yeah.
All right. Here, we also have what? No solution. Notice how they graphed it, though. Their graph up here.
Yeah. It stays in the
Okay, because we have negative 9, but what do you notice about how the graph is?
It's horizontal.
Horizontal, where's its intercept at? Y equals negative 9. Yep. What was that last? Here, let's solve this one algebraically. When it says solve algebraically, again, what does that mean? Find x. Notice what happens. What happens when I add 3x on both sides?
Oh, they cancel.
They're gone, right? So we have 6 equals 7. No solution. Good. All right, here, what's going to happen? What's going to happen here?
No solution.
No solution because those x's disappear.